So today's presentation, I wanted to race through some of the trials that we've completed, and I'll put it into context as I go through the presentation while I'm going over some old ground. So just quickly with the PCAT, I guess with that technology, I just wanted to raise that we've got some joint procurement opportunities. So you can see some prices here. Normally costs around 11,000 to 14,000 per kilometre. IWN has got a rate of 10,500 per kilometre. Where we use this technology, the trial was probably conducted, I think, a couple of years ago, and it uses a 75 kPa transient wave to do condition assessment over a couple of kilometres per day. Where we'll be using this one, Neil, is remember we had that break on Riddle Road and Elizabeth Drive, affected a lot of customers in Sunbury. We're going to run this technology again over winter when the network quietens down, and we'll do it overnight so we can maximise this transient wave when the network's quiet. The reasoning for us doing that again is that we want to know whether this was a one-off event or whether it's going to happen again. JD7, I'll quickly race through this, but the LDS 1000, the investigator was live CCTV of a water main. The investigator was inserted via a hydrant, so no customer interruption. LDS 1000 inserted via air valve, again no customer interruption. And the pipe scan plus, you know, your words, Neil, I was kicking gravel that day when it didn't work. I'm a little bit upset. But as you know, some vendors are very strong with their marketing, and your words to me at that point was that, you know, that's still not a bad result. Even though the pipe scan plus wasn't successful, we've saved everyone else going through that process. So we've done it on behalf of the industry. So long story short, not all of our trials are successful, but when they're not, like we said, we save the other water corporations going through some pain. Satellite leak detection, I've covered this a few times now. Moral of the story is you can see the results there, 18% round one, 27% round two. Not great results, but having said that, a satellite can find a leak 650 kilometres from Earth. So there is potential still with this technology, and as I go through this presentation, I'll share some more information with you. The sewer serpent, I touched on this last time. This was measuring exfiltration through a sewer network. Our validation process was where we found those points of exfiltration. We actually excavated to validate it. So we recommend that tool, that technology as a business as usual tool, but we say you need to weigh it up. It's horses for courses. You need to fill the sewer network with water, and then you run this device through the sewer network. So, well, if you've got a water main and a sewer main in a nature strip, nice and easy to use. If your sewer main's in a back paddock there and you've got to cart water in, you'll weigh up your OPEX costs to see whether it's useful or not. So what's been happening over the last 6 months? Quite a few things. The red zone solo, so I did a quick presentation last time, and that was the robot that travelled through the sewer network, could travel manhole to manhole, was unmanned, it was gathering CCTV data, and then it would retrieve itself to the point of entry. Everything worked out well. You can see there we deployed 3 robots, surveyed 2,000 metres of pipe in just under 8 hours. So you can do your own sums and work out, you know, conventional CCTV, how much you're getting per day versus this. I guess, how would I describe this? Where I can see this IWN champion group and the leadership training and all those sort of things that you're going through is that this was pretty much run by champions. So while I'm standing up here presenting on it, there was Nazrul, Dan, all involved running this within their own water corporation. So it's good to see that you guys are taking these skills on board, actually delivering projects within your own water corporation. Having said that, I'll throw it out there a little bit further and say, if you're interested in managing a project into another water corporation, let me know. Because really where I'm trying to head with this is that I'd like to have a succession plan. I look at you guys and girls as the succession plan for me. I don't plan on going anywhere unless my lucky numbers come up this weekend. But why not expose you to the program and pass on some of the learnings that I've got? So that's an open invite for any of these projects that I'm going to run you through now. Some of the learning, so this company came from America and they do things a little bit differently there, especially the way they provide the CCTV footage. So it wasn't in a format that was easy for us to use. And when they do their grading, it was different to the WASA code. So there was some technicalities around that. So our learning is that we want the footage in a format that the Water Corporation can understand, and if it's going to be coded, it needs to be to the WASA code. Also, this device worked in pipe diameters from 200 to 300, and as you would know, we've got a broader range of pipe diameters. You know, the majority is 150, so we need them to expand on that range, which they've committed to do, by the way. So we've said that if you take on some of these learnings and you want to bring the device back to Victoria, we'll give it another go. The MD profiler, that's generated a lot of curiosity, mainly with MDs. Not mentioning any names, and before you...
I think you might be going somewhere now.
Yeah, I won't ask where.
Could be a career defining course.
Is it? I thought you were offering Crown. I thought you were talking about Crown Casino.
I hope your numbers come up, then.
Yeah, exactly. In a hurry. Yeah. So this is not the... Just to clear the air, this is not the MD profiler that you're all thinking of. Having said that, I guess we'd just be reiterating about Neil's strengths, being a strong leader, visionary, innovative, all that stuff. So you can see that we got a quick result there. But anyway, yeah, exactly. So I don't need those numbers now. Anyway, to get onto the real MD profiler, so we're all on the same page, you can see the device there on the bottom right-hand side. Surveys large diameter pipes, 375 to 900, can pretty much do a kilometre in a day. Conducts CCTV, laser profiling and sonar. CCTV we're all familiar with. Laser profiling will give you the ovality of the pipe, and sonar will tell you what's happening under the waterline. So if there's a lot of silt, sediment build-up, you'll get a report on that. The luxury of this technology is that there's no bypass pumping. So as everyone would be aware, you start bypass pumping large diameter pipes, you take on a risk with that. So there's no risk. The trial included Western Water, Central Highlands and Southeast Water, and I'll share a video with you guys about that trial.
So Central Highlands Water is working in partnership with the Intelligent Water Networks, or IWN. We're trialling the MD profiler today. That's technology which incorporates laser scanning, CCTV camera footage and sonar. We are using it to assess the condition of the sewer main here. So we're doing a 1.3 kilometre section of sewer main. The diameter ranges from 600 to 750 millimetres. Traditionally we would put a camera down there, but there's sort of only so much you can see through the lens of a camera, and this technology is hoping to give us a little bit more information so we can drive better decisions in terms of how we manage this asset. Once the boat has been deployed, we'll probably be condition assessing for about 2 hours, and the whole process will probably take up most of the day, so including deployment and retrieval.
So that's another good news story too. You know, Jess ran that project. I didn't even go to Central Highlands Water. She managed it from end to end, and they followed up with a video. So again, you know, I'll say that from the champion group point of view, you know, if anyone's looking at doing something a bit different, try managing a project into another water corporation, and I can help you with that. I've had a few calls from home and away, but Jess says Central Highlands Water is a great place to work, so she's not interested. So the conclusion with this is that it delivered on its performance criteria. Again, this CCTV footage keeps popping up as an issue. It comes in a different format. We were specific about what we wanted and was a coding. My feeling on that, again, international company, that's where we're starting to get a few issues, but we've been clear about what we want for the future. Having said that, we do recommend it as a business as usual tool. Water cam group, so that was the insertion of a camera into a live water main. And that's why I wanted to touch on the JD7 trials that we conducted a few years ago. And the moral of that story is that we're not starting from scratch. We had learnings from that trial that we're going to carry into future trials. The learnings from the first trial was that the camera didn't have a self-levelling head. So when you're reviewing the footage and you're looking at sediment build-up in your pipeline, it could be anywhere. It was coming up on the side wall, on the roof, and that's because they didn't have the levelling camera. If they did, your sediment would be at the bottom of the pipe. This technology offers that. Where it's a little bit different is you can see that a tapping is required on the main, whereas with the previous technology it was inserted via live hydrant or air valve, so existing infrastructure. So the feedback that we've provided is that the The camera works good, it gave us a good indication. Having said that, we don't want to put additional infrastructure onto the pipeline. We want to use what we've got. That'll avoid us conducting tappings every time we want to have a look inside. And if we can use hydrants, well, we know we've got umpteen hydrants already in our network. We had a criteria for this trial. The contractor, vendor met all that criteria. So we recommend that as a business as usual tool. Having said that, I've touched on those points: entry via hydrant, ability to clean the hydrant out while you're doing an insertion via a hydrant, and the key thing is around no customer interruption. So the part that interests me with this type of technology is, while we're doing all this work behind the scenes, is we're going to have to engage with our customers in a different way. They'll start getting the bill, their rates, and going, oh, I don't see anything, there's no trucks happening here, we're working a little bit more discreetly. So moving forward, I think we need to change our comms strategy a little bit. When we might do a notification saying we're working in your area and you won't see us, and we're using this new innovative technology. So at least customers can see value in what the water corporation's doing in their area, and knowing that we're putting them front of mind. So we're trying to use technology that doesn't interrupt their services. That's what the footage looks like. Now the camera didn't go that far up the pipe, and you can see why. It's a cast iron pipe, it's almost fully corroded, but it's handy for the water corporation to understand how much corrosion's happened and barnacles have built up in that pipeline. Now this water corporation knew that, so it was no surprise to them, but what they're going to do is they're going to use this information to help lift the priority of that water main replacement. When you see those bars, that's just a protection device over the camera head. So there's one just there on the right hand side. It's got a little bit of a cage over it so you can push it through. The vision seems pretty clear. Sometimes it looks a little bit turbid, so as you're pushing through, if you're stirring up some flock. But overall it was a successful trial. The other thing too, or the other learning from the previous trial, is that the vendors for JD7 are all international. So if you said, oh, I've got a need today, it's not going to be likely that you'll get them tomorrow. It's probably going to be in a few months' time. This company's in New South Wales, so not in Victoria, but still can come down tomorrow if you had an urgent need. So we're looking for someone a little bit more local, and they're open to feedback. So when we talk to them about the tapping, is that they're actually developing a new device so they can do it via hydrant entry. So that's good. So we said, when you're ready, we'll trial it again and we'll share the learnings in this forum. You touched on, John, earlier about Wyoa, and I don't know, Brett's out there, it doesn't matter, is that Brett's often mentioned to me, don't just rely on your IWN tentacles, is that we've all got networks in a whole range of different forums within the water industry. So tap into the ones you've got and share your learnings. So I'm sharing the IWN story with the Wyoa Network Operator Development Program. So that kicked off last year, and the people that have been involved in operations understands that there's a network operator of the year, normally a treatment plant operator. The poor field services network guy was a poor cousin, never got acknowledged for anything until last year when this program was developed. So ultimately there'll be a Network Operator of the Year award. There was one last year, there'll be one this year. Where the IWN fits into this program is that I've got 3 core modules that are in there now. And one is about our structure and how we work. And it's interesting to see how much or how little these guys understand. So, I've identified that there's a champion within their water corporation that should be the conduit of information from IWN to their business and vice versa. I've also got a module on water-related technology, and tomorrow they're doing their wastewater module, so I'll be there talking about sewer technology with those guys, and it sort of starts to open their eyes up a bit. When you talk about leak detection, if you're a little bit naive, you'll be thinking about acoustics and walking through streets, and then you talk to them about satellite leak detection, and most people go, whoa, okay, that's a bit out there. But you can see there's a potential of doing things different ways, and that's the moral of the story with these network operators, is that we want them to think broader rather than this is how we've done it in the past and this is how we're going to do it into the future. So some good opportunities with that group. The concrete sewer pipe tester, so we're just coming to the end of those trials. That was a device that we put through concrete sewer pipes. penetrate the roof. We're looking at H2S damage, softening of the concrete walls. Some good learnings. The last application is out at Southeast Water, and then we need to think about what are we going to do with this device. I'm a bit reluctant to leave it with the Water Corporation. I don't want to find out that it's sitting in a depot gathering dust. I'd like to keep moving. You know, thinking outside the square, do we sell this device? Do we generate some revenue? Do we put it back into the IWN bucket and fund a new trial? A lot of opportunities there. So those decisions are still to come. This is the device in operation. It's hard to see, but that's the point of penetration there. Early in the piece, you know, we're trying to build a tractor and incorporate this device, and early learnings was, why are we mucking around with tractors when we've got CCTV tractors that exist already? So that's what's pushing this thing, is a CCTV tractor, just a bolt-on device, push it along, get some footage. Now the good news for us, Neil, is that this is in our area and there's not much penetration. And we can do that on any frequency. You could do it every couple of mil if you wanted to. So while there's little penetration with this concrete pipe in our network, some of the learnings that we've got is that we clean the pipe before running the device through. When we cleaned it, we removed the soft concrete that was there. So we're measuring the inside diameter and finding out it's bigger than what we thought. So we know that our wall thickness is shrinking, and we can use those details to determine the remaining life cycle of that pipe. So while we thought we were doing it one way, we've actually had some extra learnings as well. Another thing about, you know, infiltrating, sharing the story, and I was very fortunate to be able to present on that project at Ozwater. So there was a bit of interest around that as well. Satellite leak detection. So the reason I wanted to touch on the previous trial is that if you can find a leak with a satellite, do we just say, oh, well, you know, 14% first time, 27%, that's it, put in the bottom drawer? Or do we investigate further? And we wanted to investigate further. So we sent out this expression of interest and just threw it out there to find out who's doing work in that space and where are they at with this technology. In addition to that, we did an international technology scan just to see what we could find out. And what we found out is that Detection Services have partnered up with a company, Resitech, that does satellite leak detection, and they're keen to do a trial with us. They were the leading technology on our international technology scan. So these two things are starting to line up. So I can see some potential to try and progress this to see if that technology's evolved. The reason it's of interest to me, and I guess to the industry, is that when we do leak detection, we're either doing it street by street or an area. These satellites can do a corporation. So if we can get to that level, you know, you could sweep your whole corporation annually if you wanted to. So we'll see how that goes. I'll keep the group informed. I touched on that, yep, so it looks like we probably could progress something later this year. Then moving on from the concrete pipe tester, is that while we were sharing that information around the place, is that organisations came back to us and said, well, you know, what about sewer access holes? Similar story, there's a lot of them. The example I've got there is the 22,000 maintenance holes in Western Waters region, all of different condition. So, you know, I hit Neil up for some money and say, there's 100 that need to be replaced. How can I say that I'm doing a risk-based approach? Or am I just picking ones just in vulnerable areas? So what we're thinking, and we'll develop this tool, is that we'll lower it so there's no confined space entry, we'll penetrate the wall, we'll measure that, we'll compare it against our other access holes, and then we can have a risk-based approach on our rehabilitation programs. So, like I mentioned earlier, there's been some really good interest with that. You can see Golden Valley Water, Central Highlands Water, Yarra Valley, Northeast Water. So we'll get all those groups involved as this technology starts to develop. Sewer image diagnostics, it's been a real interesting space at the moment. So I guess if I explain the end-to-end process that we're trying to get to, is that, as you would be aware, you've got CCTV vans, a couple of operators, you get your footage, then someone reviews that footage, and I take my hat off to that person that reviews the footage in our business and yours. Because that's right. And the running joke is, how was your day today? You know, what do you say? You know, I got a structure 5 today. Yeah, it's been really good, and it's on the rehabilitation program. The the beef I have is that how much good pipe is this person looking at to get to these issues? So where we want to get to is we want these devices, the robots like the Solo, going through the network, collecting the data, raw data. We want to put it into a software program of some description. We want that to review all the footage, all the good pipe, take that out of the equation. Here's a minute, if that, of your structural 5 CCTV, and we'll review that. But we didn't have to review the good pipe to get there. That's where this product kicks in. So I've been talking about this for 10 years, and then when it rains, it pours. We've got multiple companies that are working in this space, and initially they were coming up to us and saying, listen, from an IWN point of view, do you want to get involved? Put your hand in your pocket and you can partner us with this. So after thinking about it, we're thinking, well, why would we jump in with any one vendor? Why don't we let these guys play it out? So now our advice is, yeah, we're definitely in the market for something. You need to evolve your technology, and whoever gets there first, come and see us, because we'll be talking about joint procurement. We've offered multiple companies in-kind support so that they're not going off on a tangent. We've provided them with CCTV footage. We've provided them with our process. So we're just sitting back now and we're watching this space, but I don't think it'll be far away. And I think that'll be a good news story. And luckily our guy at Western Water, he's going to retire in 2 years, so there's no job threat to him if we bring in technology. You know, he'd probably be sitting on a cruise or something, thinking about his involvement with this, leaving a legacy. The sewer pill, I'm going to circulate this to the champion group. So I think it was, someone touched on the Smart Water Fund, and that was the metros being involved with some innovative technology. The Smart Water Fund shut down, I think it was middle of last year, something like that. Anyway, to their credit, they said, we've got a few projects in the pipeline, pardon the punt, and this was one of them. So I'll see what sort of interest is there, but what this device is, it's a pretty much drop a pill in the sewer, off it goes. It'll give you GPS tracking where it's at. It'll take some still photos of what's going on. The disposable part will be the part that will be of interest to us. So disposable is, it's got sucked up the pump and bang, that's it, and probably put a few toxins in your sewer. So we'll need to weigh up, you know, the effect of that. But the thinking along this line is that if you drop the sewer pill in your network and it's travelling and it stops, it's a pretty good indication something's wrong there, and it might be stuck on tree roots or whatever it could be. That could be our early indication. What I'm thinking about is that if I use Western Water as an example, we've got 1,200 kilometres of sewer pipe. We've been conducting CCTV for 8 years. We're only halfway there. This is another screening device as an early indicator that something's wrong. So rather than just rely on one source being CCTV, this could be a good tool for us to identify issues in that other 50% that I haven't seen yet. What's the plan? I brought this slide up last time. It's just a personal goal really, is that, you know, in the old days, most of the trials we do at Western Water or City West, somewhere close, it was convenient. The moral of this story is that IWN, as we all know, is a state-based collaboration, and that's how these trials will work. So you can see there's a lot of little pictures around, and that's who's been involved with what. Your area, John, northeast, you know, you don't have something, but we're coming out there with the sewer manhole tester. So all I want to do is just keep populating this map of Victoria, showing that everyone's getting involved in one form or another. What I find is when I'm out at, I don't know, just say Lower Murray Water or wherever else, there's always this interest that's generated. So I think, you know, we can send emails about what the IWN's doing, but when we're doing things in different water corporations, I find that just as valuable as well. A couple of quick things, what we're doing at Western Water. We're using drones for leak detection. So initially I was dabbling with that and I thought, oh, thermal imaging, you know, we've tried that on a helicopter. This is my basic understanding. Helicopters up here, drones down there, thermal imaging, maybe it'll pick up something. What we've learnt is that, well, to explain this picture here, is we've got a pipeline travelling through here. It's through a rural area, big farming property, so you've got to get through one fence to another, notification, all the rest of it. So it's a bit of an issue. When there is a leak on the pipe, do the customers complain, ring up? No, they don't. You can see why. Happy cows, happy customers, you know. they'll probably ring us up about this in winter. Go, oh, you've got a leak on your pipe, it's too boggy, the cows are getting, stuck in it or whatever. But over summer, everyone's like, keep that quiet. And if the cows could talk, they'd be saying the same thing. So there's no incentive there for the customers to tell us. But this is what we found with this survey. Moral of this story is I'm thinking, thermal imaging sounds like a good way forward. This is how it's going to work. Didn't work like that at all. Is that a high definition photo did the trick. And as you guys and girls would probably be aware, is that over summer, you saw that previous photo, it's dry as can be. A green patch can get picked up with a good photo, and that's how we identified these issues. Thermal imaging really didn't give us much, but something else happened, as it always does. So yeah, that's a high resolution image. This one, NDVI, I can spell that. Normalised Difference Vegetation Index. And what that means is that's how that patch came up. So it's picking up healthy vegetation. So I started to think about that and go, oh, okay, that's interesting. So what we're thinking now is if you've got a sewer pipeline, and I'll use a reserve as an example, can we look at the vegetation near the pipeline versus the vegetation that's not next to it? If the vegetation is healthy next to the pipeline, you could assume that there's the tree roots are tapping into the sewer main and getting a good feed, and maybe that's a tool to pick up your next blockage. So early days, but that's just some of the thinking. So we'll see how that one progresses. And all these things will feed into Andrea's program. I mentioned last time about the tank inspections, about lighting up a tank and putting the drone over the top and all that. That was a proof of concept. Everyone seemed to be pretty excited. I was excited about it, but a little bit pricey. So we're just looking at something different. And we dropped an ROV in our tanks. And what we're finding, see those light points there? 9 times out of 10, they're bolts. As you could understand, the tank roof heats up, cools down, contracts, expands, and it's flicking these bolts out. Now there's another one, not too hard to see. So it's given us a real quick snapshot about points of ingress. If we've got points of ingress, that can affect water quality. In addition to that, we're getting some other condition assessment. So you can see with the ladder, there's the ROV there, that's a spider, and that's a chlorine tablet. These things are points of interest. So we're using this just to understand what's the sediment build up in the tank. If we're going to do a mains cleaning program, don't do it with a dirty tank because it's just going to suck all the dirty water out of that, put it in the network. So we use this to identify our issues. Moving forward, where we're going to evolve in this space is that, well, that's a visual and it's similar to the CCTV. How do we bring that back into our asset management information system? So we're currently working on a template that will provide the contractor. Contractor will do this online, and this will be in the near future, in the next 3 to 4 months. They'll also provide a rating, 1 to 5 sort of system on the ladder and the other infrastructure. So now we start to build up a history on our assets. So that's where we're going to head moving forward. This one's of interest to me. So you can't read the numbers, I can't read them from here, but what it is 2006, 2007, and that's our water events. So no one will be surprised around the seasonal patterns that happen in relation to your water work and your sewer work. So we're measuring here, so I've got 2006, 2007, I think that's 2008, 2009, 2013, 14. What we're doing is we're working with the weather company, not the BOM, but this is a separate company, in relation to those weather patterns. And what we want to understand is that how does that weather pattern affect this workload? So you can see there, I don't know how it worked for other water corporations, but March for us was right up there, another peak event. Yeah, so what happens for us is that we're dealing with this in a reactive mode. Oh, guys are continually getting busy, what are we going to do to help? And that really frustrates me. We should be using our data a lot more wiser and planning for these events. So the difference between this weather company and the BOM is that they're grabbing data from all over the place, airlines, mobile devices, government sources, heaps of information, and then what we're going to do is we're going to plot out what caused those events. So if I use Western Water as an example, and I showed you those peaks in workload, is that we're going to have a look at the rainfall, temperature, soil moisture content that led up to those events. Then what I can do this winter is look for the same pattern and go, oh, this is going to be similar to 2006, 2007. That was a flood year. Oh, hang on a minute. This pattern is starting to look like something that was 2013, 14. I better start gearing up. You know, we'll make sure we've got resources on call, all those sort of things. So again, we'll see how that evolves. It's very early days. Not to just think about ourselves, but our customers. Again, if we're forecasting a very dry summer, is thinking about our recycled water customers, we won't just surprise them. We could tell them that this is what we know. Why don't you start filling your dams up early and take the pressure off the system, knowing that they're going to need multiple fills over the summer period. Been a IBM product, and I'm not on the commission with them, but the only point was that we're doing water dynamics, so if things continue in that space, that information can feed right into it as well. Optic Fiber, I've talked about this for a little bit. What's going to happen is we're going to put optic fibre in a sewer main next month. What we're looking for is change in temperature, so we'll have the fibre in the pipe. What it'll do is if things are running at 17 degrees and you get a 10 degree input, you can question and say, well, if that matches a rainfall event, there could be a legal connection, stormwater connection. So I'm not too sure how that'll go. It was really just to let you know that it is progressing. We'll put it in the sewer main next month, and by the time we have the next workshop, I'll be able to share some learnings with this group. Cando trial, this is again just for your information, but new technology. We're running a proof of concept. What this is about is that it does continual monitoring of your sewer network, and what you can do is set the parameters of certain thresholds. If there's a breach in that threshold, it'll grab a sample straight away. Then what you can do is you can take that sample off and get it checked by the lab. Long story short for us is that we're going to do this out in our Melton industrial estate, and what we'll do is if there's any breaches, we can compare it to trade waste agreements and those sort of things. I know part of our network is very corrosive and we can't understand why, H2S issues, etc. But hopefully this will start to pinpoint some of the issues that we're facing, and like I said, we'll backtrack through the network to find out what's going on.